Scene script. Have you ever wondered, what if you fall into a black hole? What would happen? Would you survive? Now, before we dive into the abyss, let's pull the brakes and take a moment to unravel the mystery that is a black hole. Envision a place in space where gravity pulls so much that even light, the fastest thing in the universe, cannot escape. This region, my friends, is what we call a black hole. The concept of a black hole is a fascinating paradox of the universe. It's a place where the rules of physics as we know them seem to twist and turn, and sometimes even break. A black hole is not black in the traditional sense, nor is it a hole as we understand it. It's a dense, heavy mass with a gravitational pull so strong that it bends space and time around it. Imagine you are holding a rubber sheet, and you place a heavy ball in the middle. The sheet dips due to the weight, right? Now, if you roll a smaller ball along the sheet, it would move towards the heavier ball, almost as if it's being pulled in. That's a rough representation of how a black hole works. It's like that heavy ball, bending space around it. Black holes are the ultimate cosmic quicksand, silent and invisible, lurking in the dark corners of galaxies, including our own Milky Way. The intriguing part is that we can't see them directly. We only know they exist by observing the effects they have on the objects and light around them. The mystery of black holes is not just a question of what they are, but also how they affect the universe around them. They play a crucial role in the life and death of galaxies, in the creation of stars, and possibly in the very structure of the universe itself. But to understand what happens when you fall into a black hole, we first need to understand what a black hole really is. Black holes are not just fascinating, they are also the result of a fascinating process. Now you may wonder, how does something as mysterious and powerful as a black hole come into existence? Well, the answer lies in the life cycle of stars. Just like humans, stars have their own life cycle. They are born, they live, and eventually they die. But unlike humans, the death of a star can result in the birth of a black hole. Let's delve into this process. Stars are massive celestial bodies made up of hydrogen and helium. They shine brilliantly because of a process called nuclear fusion, where hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the process. This energy exerts an outward pressure, counteracting the force of gravity pulling everything inwards. This delicate balance between the two forces keeps the star stable throughout its lifetime. But what happens when the star runs out of fuel, when there's no more hydrogen to sustain nuclear fusion? Well, the star begins to die. The outward pressure decreases, and gravity gets the upper hand, causing the star to collapse under its own weight. The core implodes, and the outer layers are blown off in a spectacular explosion known as a supernova. Now, the fate of the star post-supernova depends on its mass. If the star's mass is about 3 times or more than that of our sun, the core collapse continues until it becomes a point of infinite density, known as a singularity. This singularity is shrouded by an invisible boundary called the event horizon, beyond which gravity is so strong that not even light can escape. And voila, a black hole is born. Black holes, thus, are the final evolutionary stage of some of the most massive stars in our universe. They are the remnants of once vibrant, shining stars that have burnt out all their fuel and succumbed to their own gravity. So black holes are essentially dead stars, but with gravity so strong that it devours everything around it. A black hole is not just a hole, it has a structure, albeit a very strange one. Let's start with the event horizon, the most visible part of a black hole. Imagine a boundary line in space, a point of no return. Once crossed, there's no coming back. That's the event horizon. Nothing, not even light, can escape it. Hence, the blackness of the black hole. It's like the ultimate one-way street, leading only to the heart of the black hole. Now, what lies at the heart of a black hole? That would be the singularity. It's the core, where all the mass of the black hole is concentrated. Picture an extreme density, a point in space where gravity is so strong that it warps and twists the very fabric of space and time. This is where things get a bit mind-bending. Singularity is a place where our standard laws of physics no longer apply. It's a place of infinite density and nearly zero size, which is quite hard to comprehend. But before we get to the singularity, let's not forget the accretion disk. It's like the black hole's dinner plate. When a black hole is feeding, it pulls in matter from its surroundings. This matter doesn't fall straight into the black hole, though. It spirals around it, forming a flat, rotating disk, the accretion disk. This disk is super hot due to the friction between particles and shines brightly, often outshining the stars in its vicinity. So, a black hole is more than just a void in space. It's a cosmic beast with a boundary line that traps everything, a heart of unfathomable density, and a glowing dinner plate for consuming matter. It's a fascinating yet terrifying cosmic phenomenon that stretches our understanding of the universe. And within this complex structure, the laws of physics as we know them seem to break down. If you think black holes are just sitting there doing nothing, you're in for a surprise. Black holes are the universe's most captivating enigmas, and their effects are nothing short of mind-bending. For starters, black holes distort space and time, a phenomenon we call gravitational lensing. Picture this. You're looking at a star, its light travels in a straight line, right? Well, not if a black hole gets in the way. That light will curve around the black hole, creating a sort of cosmic mirage. It's as if the fabric of the universe itself is being stretched and pulled, like dough in the hands of a cosmic baker. But the effects of black holes are not limited to bending light. They also play a crucial role in the formation and evolution of galaxies. In the heart of almost every galaxy, including our own Milky Way, lurks a supermassive black hole. These monstrous entities can contain the mass of millions or even billions of suns. As they consume matter, they create a swirling disk of gas and dust, a quasar, which can outshine an entire galaxy. This process helps to regulate the growth of galaxies by controlling the amount of star-forming material. Black holes also influence their surrounding environments on a grand scale. They can launch jets of particles traveling at nearly the speed of light across thousands of light years. These jets can trigger the birth of new stars in their path or conversely blow away the gas needed to form new stars, effectively stifling star formation. But perhaps the most intriguing effect of black holes is their ability to spawn new universes. Yes, you heard it right. Some theories propose that every black hole could house a universe, with laws of physics different from our own. If this is true, then our universe could be nestled within a black hole in another universe. Mind-boggling, isn't it? Black holes may be invisible, but their effects on the universe are far from it. Now back to our initial question, what if you fall into a black hole? Let's find out. Imagine yourself drifting in the vastness of space and being drawn towards the intense gravitational pull of a black hole. As you get closer, the extreme gravitational forces start to stretch and squeeze you. This is the intriguing yet unnerving phenomenon known as spaghettification. The term spaghettification, coined by the brilliant physicist Stephen Hawking, refers to the process where an object falling into a black hole is stretched into long, thin shapes like spaghetti due to the intense tidal forces. Why does this happen, you might wonder? Well, black holes have such strong gravity that the pull varies drastically over short distances. If your feet are closer to the black hole than your head, they would feel a stronger gravitational pull. This difference causes your body to stretch vertically while being compressed horizontally. Hence you're turned into a sort of human spaghetti. But let's not forget about the intense time dilation effects near a black hole, a concept arising from Einstein's theory of relativity. To an outside observer, it would appear as if time has stopped for you. They would see you falling slower and slower until you seem to freeze entirely, suspended at the event horizon, the point of no return. Inside the black hole, reality as we know it breaks down. The laws of physics cease to apply and space-time warps and twists in unimaginable ways. It's a realm shrouded in mystery, a cosmic enigma that continues to baffle the greatest minds. However, it's important to remember that this journey is purely hypothetical. As of yet, we don't have the technology to safely send anything or anyone into a black hole. And even if we did, they wouldn't be able to tell us about their experiences. Information cannot escape a black hole, hence the term black. So, the journey into a black hole is a one-way trip, with a rather unpleasant end.